an intro to mysteries of chemistry or primes? Which one's next?
Mind if we do the primes?
Okay, primes. Do you guys want to throw out any of your background knowledge of what the primes are, what the mystery behind the primes is, or even just the topic of what they are? You want to give it a go?
From my basic naive knowledge, basically you have a prime. Definition is something that's divisible by 1 and itself. Because I know we had the talk before because I was told 1 is prime. I'm like, okay, well, somebody said that. Is that true? That's a very interesting other story. So, and as far as I understand, from the primes, we can construct essentially all the other numbers, which is also interesting. Right, but is there a way we can actually find out to predict how many primes? Because you start off, you get 1, 2 is essentially the only even prime there. You get 3, 5, 7, so on. And then there seems to be a very large gap, but it seems to go on forever. Why? Can we figure out what's going on? And basically that's about my limit of the knowledge. I just know they're very important, and a lot of people are very interested in how we get there. And it sounds like we're getting very close.
Yes. Now,
That's all I got.
do this in a leading way because I want to see.
Okay. Yeah.
I'm trying to get it.
Yeah.
You know that.
Yeah.
Okay. Let's put up a list of the. Actually, before we say primes, let's do factorizations. Let's write out a trivial sequence, the trivial sequence of factorizations. So if you want to factor something once, or not at all, let's factor 0, then you just do x to the 0. Okay, the something is the x. We haven't said what, so it's a generalized thing. But if you want the trivial sequence, then you say x to the 1 plus x to the 2 plus x to the 3 and so on, right? Now, in generating functions, what you do is you take a factorization sequence and you'll apply it to something you want to make sense of, like, say, the sequence of primes. So let's rewrite this now, but let's put a coefficient with each prime. And allow me, people might want to be uncomfortable with that, I want to call, just so it's easier to write notation-wise, 1 the 0th prime. Allow me to do that so I can write it easier, right? So here, I'm going to put 1 x to the 0, because 1 is the 0th prime, plus 2 x to the 1, because 2 is the first prime, plus 3 x to the 2, because 3 is the second prime, and so on, right? Now 5 x cubed, 7 x to the 4th. You see how it goes, right? This whole thing gives you what? What does this sequence represent now? Or understand what's going on. Yeah. So we're putting the sequence of primes into the trivial factorization sequence, and then asking, here's the big step, setting the whole sequence equal to 0, and then asking what x does this? Nope. There's 2 numbers actually to do it. I mean, I don't know what symbol is the standard to put. I don't know if there is a standard symbol. Let me for now just call them x0 and x1. I'll call them that. We can invent whatever we want, I guess. We call them. But there's a number, or I don't know what the number is, I haven't memorized it, but there's a string of digits and a string of digits for both. So there's 2 solutions that you can put into x. You just put it in every place, multiply it, or take it to its power, multiply it by its coefficient prime, and when you do, all of these primes go to 0. The whole balance becomes a 0 balance, but only at these 2 numbers. These numbers are the numbers that satisfy this, and no one has any idea how to figure out why